Okay, for this video we're going to talk about solving with variables on both sides. There is a PDF available. You can go ahead and print that out if you'd like. We're going to jump right into the steps. You might notice that these steps are exactly the same as solving multi-step equations. The only difference is now that we have variables on both sides, we can actually do step 2, which is move all the variables to one side or the other. One thing you want to keep in mind about these rules here, these steps, is they also work for inequalities. So multi-step inequalities, the same rules apply. The only difference is when you get down here to step 3, if you ever have to multiply or divide by a negative on both sides of the inequality, you have to flip the inequality symbol around to keep it true. Let's go ahead and start with the problem. There's nothing to simplify on both sides, so I'm actually done with step 1. So go to step 2, and it says to move the variables to one side. Well, I look at the coefficients. This is a -8. That's a +4. This one is smaller, so I'm going to add 8x's to this side. Now I can move the 4 to this side if I wanted to, but the reason I moved it this way is so that I end up with a positive coefficient instead of a negative coefficient. The coefficient, again, is the number that's out in front. Actually, this one's a negative. I still have a 7 here, so bring the 7 down because this is just 0. And then 4 plus 8 leaves us with 12x's and a -17. Now that my variables are all on one side, I can go to step 3, which is isolate the variable using reverse PEMDAS. So I'm going to undo the minus first, so add 17, add 17, 7 plus 17 is 24. This is 0, and I still have a 12x left over. Last step, undo the times by 12. We can go ahead and divide by 12, but I'm going to show multiply by 1/12, the reciprocal, because sometimes we're just going to have to deal with fractions, the reciprocal. So 24 times a 12th is 24 over 12, which is just 2, and 12 times a 12th is 1. 1 times x is x. The alternative to that is just divide both sides by 12. However, there will come a time where we can't just divide by that number. Next example, I think I have this on here twice. Yes, I do. So I'm going to show you how to deal with this fraction 2 different ways. The first way is just to go ahead and distribute. So 1/4 of 16 is 16 over 4, which is 4. 4 times x is x. And then distribute to the 60. So 1/4 of 60 is 60 over 4, which is 15. This side here, we didn't do anything with, so I'm just going to bring it straight down. Now I'm going to look at my coefficients. This one's smaller than this one, so I'm going to get rid of the 4x's on this side. So subtract 4x's gives me 0x's, leaves me with 15 over here. 9 minus 4x's leaves us with 5x's minus 5. Now that I have x's all on one side, all I got to do is use reverse PEMDAS to isolate x. So I'm going to get rid of the -5 first, and the last thing to go is almost always the coefficient of your variable you're solving. So go ahead and add 5 to both sides. We have a 5x over here because that's 0. It's still equal to 15 plus 5, which is 20. Last thing we have to do, divide by 5 on both sides, and that's a 1. That leaves with x equal to 20 over 5, which is 4. Okay, so we went ahead and distributed the 1/4. We just dealt with the distribution of the 4, the fraction, and it ended up clearing itself out, and we got a value of x equals 4. Okay, so on the next option, I'm going to show you how to clear this fraction out, or use a reciprocal actually, multiply by the reciprocal. And the reciprocal of 1/4 is just 4. So I'm going to times by 4. Oops. Times by 4 there, times by 4 here. I'm multiplying the entire thing by 4. Well, 1/4 times 4 will end up giving you 1. And 1 times anything, that's the multiplication property of identity, will just leave us with 16x plus 60. Now over here, I still have to go ahead and distribute my 4. So 4 times 9 gives you 36x. 4 times -5 leaves you with -20 or -20. Now that I've simplified both sides, I'm going to go ahead and look at my coefficients on x's. This one is smaller than that one, so I'm going to eliminate the 16x from this side. And to keep it in balance, I have to eliminate 16x's from this side. So 36 minus 26 leaves you with 20 x minus 20. 20x minus, so I didn't touch the minus 20. And 16 minus 16 is going to be 0 plus 60, which leaves you with 60. Now that my x's are all on one side, I'm going to isolate using reverse PEMDAS. Again, coefficient almost always goes last, so I'm going to get rid of this first. Plus 20 on both sides. This is 0, bring down the 20 x's. And 60 plus 20 is 80. And now to get rid of the times 20, divide by 20 on both sides. So this has become a 1, and x will equal 80 over 20, which is really 8 over 2, which is 4. If we go back and check, our previous problem had x equal 4 when I distributed the 4, 1/4, and I get x equals 4 when I went ahead and multiplied by the reciprocal, which in effect, this one, since it has a numerator 1, is really like clearing the fraction as well. Clearing the fraction, well, since the numerator is a 1, I can't really do anything else with it, so there's no point in showing clearing the fraction. Okay, here we go. Another example. I can't combine my a's with these a's over here because it's still inside parentheses, so you must first distribute. So 5 times a is 5a, 5 times the negative 3 is negative 15. Go ahead and write that a little better. And over here I did not do anything with this side, so it's still 3 minus 4a. Now I look at my coefficients of my a's because I've simplified both sides. I go on to step 2, which is decide which a I'm going to get rid of. Well, these are smaller. Negative 4 is smaller than 5, so I'm going to get rid of that by adding 4a. But to keep the whole thing in balance, I have to add a 4a to the other side as well. So this is 3 plus 0, which is just 3. 5 plus 4 is 9 times a, and then I have a minus 15 still. Now that my variable's all on one side, I'm going to isolate using reverse PEMDAS. Again, this is almost always going to go last, so I'm going to get rid of the minus 15 by adding 15. I still have a 9a plus 0, which is just 9a, and then 3 plus 15 is 18. And this is actually a. And all I got to do now is divide by 9 on both sides. This is a 1, so that a will end up equaling 18 over 9, which is 2. Keep in mind that you should take this number, put it back in place of a in the original problem only, not this problem, the original problem, and check to see that both sides actually are equal. Here's another one. Can't combine my z's with z's here until I first distribute, so I have 5z minus 2 equals 2 times 3 is 6z, and 2 times negative 4 is negative 8. That's the letter z. Now that my z's have been, or both sides of my equation have been simplified, I now decide which of my z's to get rid of or move them all to one side. This is smaller than that one, so I'm going to minus 5z from both sides. This is 0. 0 minus 2 is negative 2. Yes, the negative must come down with 2. 6 minus 5 is 1. 1 times z is just z. And I still have a minus 8 on that problem. Now all I got to do is get rid of my 8. Remember, I'm trying to isolate the variable, so get rid of everything that's with that variable. So negative 8 plus 2 is going to give us 6. And z plus 0 is just z. So z would have to equal 6 to make this equal, make the left-hand side equal the right-hand side. Okay. Little word problem here. Car dealership sold 78 new cars and 67 used cars this year. That sounds like it's important. Oops. This year. The number of new cars sold by the dealership has been increasing. So the new cars has been increasing 6 cars each year. So 6 cars each year. 6 is actually, or each is actually an important piece of information that either means multiply or divide. So if it's 6 cars each year, 6 the first year, 6 more or 12 the following year, and then 6 more after that would be 18. So that's actually a multiplication. So this each means multiply, not divide. The number of used cars sold by the dealership has been decreasing by 4 cars each year. So that's going down. Decreasing means going down, but 4 cars, again, each year. So this is getting smaller. But it's still a multiplication, 4 cars per number of years. If this trend continues, in how many years, right there, years, that's what they want to know, will the number of new cars sold be twice the number of used cars? Okay, the question is how many years? So we're going to go ahead and define, let's use y to equal number of years since this year. Okay, again, they sold 78 cars, new cars, and 67 used cars this year. And we want to know how many years before the number of new cars will be twice the amount of old cars, or not old cars, but used cars. So y stands for the number of years since this year. Okay, so basically we want new cars to equal 2 times the used cars. That's what they're saying. In how many years will the number of new be, which is like saying equal, so new will equal twice the number of used. So twice means times by 2. So used cars times 2 was equal to new. Okay, now the question is, how do I figure out what the new amount is? Well, we know what we started with in this year was 78. So new consists of 78. But it's increasing, which means plus. And how much is it increasing by? 6 times the number of years. Well, y is the number of years, so this is going to be 6 times y. So the number of used cars is how many we have this year plus 6 times the number of years increase. And then we want to figure out to get double the used cars. So 2 times the used. You'll notice that I put used in parentheses because it's 2 times used. So I have to put 2 times parentheses. This year we have 67, so let's start with 67. And it says that they are decreasing, which is a minus, but it's decreasing at a rate of 4 cars per year for each year. That's the same thing as 6 cars each year. So it's 4 times the number of years, just like this was 6 times. 4 times y. So used cars times 2 equals new cars. New cars is getting bigger, used cars amount is getting smaller. How many years before the new cars amount is equal to twice the used cars amount? Use a calculator on these. We're still going to go ahead and solve multi-step by first distributing. Okay, so 67 times 2 is 100, and I think that's 134. Let me just double check the number. 67 times 2, 134. Minus 2 times 4, which is 8y. I still have a 6y and a 78. Okay, now that I've simplified both sides, look at my coefficients on the y. I have a -8 and a +6. This one's bigger than that one, so I'm going to get rid of the 8y by adding 8y to both sides. And I still have 78 plus, 6 plus 8 is going to give us 14y. This is a 0, and I still have 134 on this side. You know, we have to get this out of the way. Now that my y's are all on one side, I just use reverse PEMDAS to solve. This is a +78, so I'm going to minus 78 from both sides. I still have 14y equal to 134. This is 134 minus 78. Make sure you use your calculators on that. Get 56. And then now all I got to do now is divide both sides by 14. So that y should equal 56 divided by 14, and y should equal 4. So what does y stand for? Y stands for a number of years since this year, and what's the question? In how many years? 4 years before they're equal to each other. Okay, we've got one more thing here called identity problems or identity equations. And it has to do with how many solutions an equation has. We're going to find out now that sometimes our equations will have one solution, but sometimes they'll have either no solutions or an infinite amount of solutions for the variable. Okay, so number of solutions. Equations do not always have to have one solution. An equation that is true for all values of the variable is called an identity. So if it doesn't matter what I put in for the variable, if it's always going to come out true, we call that an identity. So the solution of an identity is all real numbers. Some equations have no solutions. Okay, so one of these will have no solution, the other one will be an identity. The only way to know for sure is to go ahead and solve for x. So the first thing I'm going to do is distribute. So I have 3x is equal to 3 times x is 3x plus 12. Move my x's to one side, so I'm going to minus 3x, and it turns out that I have 0 is equal to, this is 0 plus 12, which is 12. Well, 0 does not equal 12. What happened is my x values dropped completely out of the problem, and when that happened, the statement that was left over was not true, which means since the variable drops out of the problem, it doesn't matter what I put in for the variable, the equation will never be true. Okay, so this particular problem here has no solution. So anytime your variable drops out of the problem, you've got one of two scenarios going on here. It's either no solution, or it's going to be an identity, in which case any number for the variable will work. So what does that look like? Let's go ahead and take a look at an example of an identity. Over here we're going to distribute the 2. So I have 2x plus 10 is equal to 2x plus 10. If I move my x's all to one side, what happens is I get a 0 here and a 0 here, and all that's left over is 10 equals 10. Notice here it says 0 equals 12, which is not true. Over here 10 equals 10, which is true. Since the variables dropped out of the problem completely and what was left over was still true, it doesn't matter what I put in for the x value. The left and right hand side will always be equivalent. So this kind of problem right here, where you're left with no variables but the statement that's still there is true, we call that an identity.